Okay, here's the key to review. The first one, we have values of arithmetic sequence a sub n and geometric sequence g sub n are graphed in the figures below. Write 3 expressions for the nth term of each sequence. Okay, so if I have a question like this, it is going to be a multiple choice question. It's not going to be an FRQ. So I first need, clearly this one's arithmetic. First of all, it said that to me, plus it looks linear. So in order to do that, when you're looking for the common difference, it really is just the slope. And so you can use the a sub n formula. I mean, we have that. That is a sub n equals a sub k plus d times n minus k. I mean, we're going to use that anyway, but we can put 2 ordered pairs in there and do that and find the slope, but we also just know how to find slope. So first of all, our common difference is, or our slope rather, common difference, whatever, it is negative. And then I can count. I don't know that I want to use that because it's halfway, but if I go from here to here, I go down 1 and over 2. So that would be a negative 1/2. Right? That's your D. Then I've just got to figure out some a sub k's to use. So I can pick some ordered pairs. Got this one here, which would be 1, 5. And I can pick that one, which will be 3, 4. And I can pick that one, which is 5, 3. And really, it doesn't matter if you pick different ones. It's totally fine. But remember that these ordered pairs are n, comma, a sub n, or k, comma, a sub k, right? So when I go to write these over here, I'm going to use these as my a sub k, or I'm sorry, my k and a sub k. So a sub k is 5 plus d times n minus 1. And then I can also have 4 plus, oh, I know what d is. That was dumb. D for dumb. Oh my goodness. All right. I'm not starting off very well here. Let me do that again. 5, and then I can do plus, but it's really a negative. So negative 1/2, that's your D, times n minus the k is 1. I got those from here. Then 4 minus 1/2 times n minus 3. Got those from right here. And then 3 minus 1/2 times n minus 5. Those are just the 3 that I happen to pick, but again, you could pick other ones. All right, so then over here, now, just like in any line when you do slope, I can pick any 2 points and find my slope. If I want to find r over here, to use my g sub n equals g sub k times r, the n minus k. If I want to find r, it's the common ratio. I can't use any 2 points. I have to use 2 consecutive points. So I can use these 2, or I can use these 2, or these 2. But I also don't want to have to guess at what the y value is. So these look like good points. This one is at 112. And this one is at 2, 8. So to find my common ratio, I'm going to put 8 over 12. And that reduces to 2/3. Okay, so r is 2/3. And then I need 3 points here. So g sub n, remember this is going to be my either n, comma, g sub n, or k, comma, g sub k, something like that. And so I can use g sub n, and then my g sub k would be 12 times 2/3 to the n minus 1. I got the 12 and the 1 from here. Then I can do 8 times 2/3 to the n minus 2 power. Got that from here. Now, even though I don't want to guess, I don't have to guess. I know what r is. It's 2/3. If I take 8 and multiply it by 2/3, I will get this y value. So 8 times 2/3 is going to give me 16/3. So then my last one can be 16/3 times 2/3 to the n minus 3, excuse me, n minus 3 power. And if these are multiple choice questions, once you figure out this or this, then you can use these points and substitute them into your answers to see which ones work. All right, 2-2. Selected values of several functions are given in the table below. For each table, determine if the function could be linear, exponential, or neither. So those are our only options. So the first thing we look at is our change in our x's. Okay, so these are all changing by 2. I have equal length input value intervals. That's what that tells me. And then I can look at my differences here. 9 minus 12 is a negative 3. 6 minus 9 is a negative 3. This is negative 3, negative 3. So I have a constant rate of change there, which means this would be linear. So I can say f of x could be linear. Say output values change at a constant rate over equal length input value intervals. All right, so let's look at B. I have equal length input value intervals here again. So when I do 9 minus 16, that's going to give me 7. Then this gives me 5. This gives me 3. This gives me 1. So we're not changing at a constant rate, so it's not linear. Then I can look to see if I have a common ratio. I can put 9 over 16 and then 4 over 9. Those are not the same, so this is going to be neither. I'm going to say output values are not changing at a constant rate or proportionally over equal length input value intervals. Okay, well, I didn't leave myself near enough room to write the last one, but that's okay. All right, so here, equal length input value intervals, it is okay that they're not 1, but they are the same. So if I do 8 minus 16, that's negative 8. This would be negative 4, so not changing at a constant rate, not linear. But if I put 8 over 16, gives me 1/2. 4 over 8 gives me 1/2. 2 over 4, 1/2, and then 1/2. Okay, so they are changing proportionally, which means h of x could be exponential output value intervals. No, I'm sorry, output values, not output value intervals. Output values are changing proportionally over equal length input, that says input, whatever, value intervals. Sorry, totally running out of room there. Alrighty. So we're going to find the key features for each of the following functions. So we're going to sketch the graph. And this is just a rough sketch. We are not, no X and Y's. We're not making little hash marks or anything. I look at B here. Remember, these are all in the Y equals A times B to the X format there. So since this is greater than 1, it is exponential growth. And since this, if that's 1/2, it's just going to squish it down some, but you're not going to be able to tell from my sketch. It's not negative, so it doesn't flip it over. So it looks something like, doesn't really kick up at the end. It looks like this. All right. And remember that you have an asymptote here. Okay. So this is exponential growth. The function is increasing. It is concave up. Since it is concave up, okay, so let's write out our fun chart also. Since it is concave up, it has an increasing rate. Then we write our end behavior. So the limit as x approaches negative infinity. What was this one's name? This is f of x, and the limit as x approaches infinity of f of x. Okay, so when I look up here, as I'm approaching, as my x is getting infinitely small, y is approaching 0, and when x is increasing without bound, we are approaching infinity. All right, let's look at this next one. Okay, so we've got, I look at B, pi over 6. I don't have to know exactly what that is. Pi is about 3, so about 3 over 6 is going to be less than 1. So that's exponential decay. 5 would stretch it, but it's not really going to change what my sketch looks like. And it doesn't reflect, so it looks like this. And don't forget that you have an asymptote here. Okay, perfect. And so this is exponential decay. The function is decreasing. It is concave up. Since it is concave up, still we have an increasing rate. This is called g, so let's write these out. The limit as x approaches negative infinity of g of x equals, and the limit as x approaches infinity of g of x. Okay, so I want to look back up here. As x decreases without bound, y is approaching infinity, and as x increases without bound, y is approaching 0. All right, so then here we have pi, which is 3. It's greater than 1. Looks like this. However, we have this negative here, okay? And when it's negative, it's going to reflect it in the x-axis, so it looks like this. And we still have an asymptote right there. Now this one, and I realized when I was doing this, we didn't talk about this that much, but this is neither exponential growth or decay. We can only talk about exponential growth and decay if A and B are both positive. And so it's neither. Once you reflect it, it's neither one. So that all happens before a reflection. And then this is clearly decreasing, and it's concave down. And since it is concave down, the rate is decreasing. This one's named h, so let's write this out. Limit as x approaches negative infinity, h of x. Limit as x approaches infinity, h of x. Okay, so as x approaches negative infinity, y is approaching 0, just from underneath this time. And then as x increases without bound, y is approaching negative infinity. Okay. All right, Now we are going to rewrite some in to get this form where a and b are positive constants. So this is being multiplied, or I can rewrite this. That might help some of you if I rewrite it as f of x equals 3 times 27 to the x times 1/3 power. That's basically what's happening there. And then to undo our power to a power, we can do 3 times 27 to the 1/3 power to the x power. Well, 27 to the 1/3 power is the cube root. So we get f of x is equal to 3 times 3 to the x power. All right. G of x. So here, this is being subtracted. So remember when you add and subtract exponents, that's because you were multiplying their bases. So we can rewrite this as 8 times 4 to the x times 4 to the -2 power. So this is 8 times, well, 4 to the -2 power is going to be 1/16. And then I still have 4 to the x power. So g of x will equal 8/16 is 1/2 times 4 to the x power. Here again, they're being multiplied, so that's when we have our power to a power situation. This will be 1/2 times 2 to the 5th. Well, they didn't have to be in parentheses, but, well, shoots and ladders, yeah. It does have to be in parentheses. 2 to the 5th to the x power. And then 2 to the 5th power is 32, so this is 1/2 times 32 to the x. I absolutely cannot multiply those two numbers together because this one has an exponent on it, this one doesn't. I was able to multiply these because they do not have exponents on them. All right, so this is this same type of situation here. We'll have 3 times 2 to the x times 2 to the 4th. This is going to be 3 times 2 to the 4th is 16 times 2 to the x. So that means that j of x is equal to 48 times 2 to the x power. Okay. There you go. That is the end of part 1.